Uh, so a very good evening to everyone who has joined us from India. Uh, so my name is Monish Kamlaksha. I am the manager here at Make My Technology, your 5G industry partner. So first of all, thank you everyone for taking out your valuable time and joining us in this webinar where we just not only talk about open source 5G but also are going to be talking about a very important tool that has been developed by MMT's very own. So without any delay, let us just begin. So yeah, just a little brief about what Make My Technology does and where we have pivoted ourselves towards colleges. So we are an end-to-end 5G deployment company, which works hand in hand with engineering colleges and research departments uh, in the 5G and 6G era, right? So as you can see in front of your screens, this entire application tree that you could see, from whether it to be the G Node B to the 5G drone, the IoT gateway, AR, VR, we do the end-to-end complete package, whether it comes in terms of curriculum or it would be in terms of research or it could be in terms of a center of excellence, which I would be talking again later. So we are not just in the let me say in the technology of giving you a lab setup, right? We are in the business of providing a platform for 5G research, would help you upskill not just your faculty or your students, but even be industry partners to other startups or other industry-oriented objectives. So the what you see in front of your screens is actually a platform that's developed by Make My Technology, which has the COTS platform, which is developed in-house, which can handle more than 128 devices wirelessly. So we are a technology-driven company which actually manufactures everything in India and develops all of our softwares in-house itself. So, what makes the Make My Technology 5G ecosystem quite different is that we are not just concentrated in the domain of wireless technologies. We do begin with that, but as we know that, colleges have a certain requirement that when it comes to attaching themselves to technology and having it taken forward to their students, which would then turn into placements. When it comes to that, Make My Technology actually walks hand in hand with several colleges, and it has worked hand in hand with several colleges itself to provide them what you see in front of your screens. So an end-to-end 5G lab setup, that would be your GNB, your 5G SA core, plus our proprietary COTS platform and private SIMs that we give by ourselves, plus the training that would enable you to take this technology to your frontiers, right? Apart from that, we also have dedicated 5G projects such as the Kavach 5G 2.0, the SA core development projects, and the LoRa gateway development projects. So just by the gist of it, I think, ladies and gentlemen, you would have understood that these are just not projects that are for the students, but these are actual projects that have a scalability to be that of a product, right? A product that you later one day take into the market and you could be the enablers of 5G technology too. Apart from that, if you could also, look at the center of excellence, we do begin with the 5G new radio lab, but we also have an IoT lab within it. We have a GNU radio communication lab, and very soon enough, we are going to be having a new extension of the drone, AIML, and quantum computing lab as well. So as whole, Make My Technology always has been following this umbrella opportunity where we encapsulate all the requirements of our client colleges and universities and try to give them the best. Yes. A such similar example is that of SSM Dindigul, where we had successfully trained 28 faculty members in 5G SA architecture, core plus WAN signaling procedures, and a practical understanding using real-time logs, right? So this is where we also love to train the educators in 5G so that they will be taking it ahead. This is just one of the cases. where we have done excellence in the field of training our educators as well. These are a few of our clients that we have been able to give labs under the Bharat 5G. We were one of the 25 colleges have our 5G lab setups, and these are a few of them that have it. Now, coming down to a very important, let me just say, not a product, but again, the infrastructural pipeline that we have developed, which is our center of excellence, where we have encapsulate the 5G, 6G, IoT, AI, robotics, quantum, the leading fields of tomorrow's future. Is something that MMT has successfully brought under one roof. So to begin with, we have our own studio core, right? So in the studio core, we have 14 plus network functions, which are relation 19 3GPP compliant, and they are private 5G ready, right? So you have your full 5G SA core, which handles voice and video over the new radio, IMS, VONR, and VINR included, right? Mission critical, automotive, and satellite all under one, which means that V2X modules, MCX modules, NTN, and eSIMs are all integrated into one platform itself, which in the market currently in India, I doubt that anyone would be giving these to colleges and universities to train upon or to use upon. Now, apart from giving you just the software, we also give you test cases, or in the common language as we call them, experiments, right? Preloaded with 202 protocol test cases, which are designed over 19 robot framework suites with 9+ feature areas comes our studio test bench, right? This is a tool not just for 5G protocol test and validation, but actually covers the end-to-end GNV and UE emulation against any 5G core, right? This is also something that has been developed within our lab itself, within with our GNV, and this is ready for the universities to adopt. Our studio GNV. So this is a hardware component. Now, unlike other SDR solutions that you must have seen in the market, we have a G-Node B solution that operates on the N78 band, that is a 3.3 to 3.8 gigahertz, 4x4 MIMO, and 100 megahertz TTD carrier. Now, since this is on the N78, we also, are not required or registered very harshly by the DOT to have a certificate, which means that on day one, you could begin your work. But at the same time, we work hand in hand with our clients to actually make sure that they are in a position where they can practice their projects, teach their curriculum, as well as train the faculty as well. Now, Studio Fleet, right? So we have covered the software, we covered the hardware aspect of it. Now we come to something where, it is what 5G is meant for, a multi-device operation. So the Studio Fleet is another feature of the 5G 6G Studio, which incorporates the capability of 128 devices or 128 UEs in one private network, right? So a server companion to the Studio Field, it coordinates fleets of phones for parallel drive test, aggregate KPIs, and analysis of the logs with AI grounded in the 3GPP cortex, right? So this is just not a tool for you to teach students, but also a research platform where you can prove your theses, or you could even try creating new applications that you could then give as solutions in the market. Coming finally to the Studio Academy, an inbuilt academy for engineers who want to uplift themselves in 5G, combined with 50 hours of MMT course, live 5G core labs, and an AI multi-model tutor. Never before has this ever been presented to colleges and universities together as part of one platform, but Make My Technology makes it possible. Now, this is just a pinch of what we have to offer to all colleges and universities, but this is not where the buck stops. It's where it begins. Now, without taking any more of my time from Mr. Nitin, I'll just conclude this on a note that Make My Technology is your 5G partner. We are waiting for your next move. Thank you.
Yeah, thank you, Monish.
Yes.
So we'll start our today's technical webinar.
Yes, sir, sure.
Okay. Is my desktop visible?
Yes.
Yeah, hi everyone. Good evening. Yeah, I'm Nitin. So today we'll be talking about how to debug or how is it possible to debug 5G networks using the COTS UE site logging tool. So this is a quick introduction of mine. I did my MTech from IIT Delhi. I have worked in multiple companies, starting with CRM. My last startup, actually, my last organization was a Leapfrog Semiconductor, a 5G startup. And I also worked in IST open source project for 5G. That was for a few months. So basically, my expertise are in wireless signal processing and cellular systems across the full product life cycle. So at present, I am actually consulting to Bixby, which is a company for holding the MMT, Make My Technology. Yeah, so this is the agenda of today's talk. We'll be talking about what is the importance of the right tools. We will introduce the UE side logging tools. After that, we will have an overview of the Mobisync logger for the COTS UE. Then the number 4, we'll discuss some scenarios for the where the which are very much relevant to an actual systems and the problems which are faced, and we will see how those scenarios can be handled and debugged and fixed. We'll have a live demo for the tool. For that, we will use as a 5G network, we'll use an open source 5G RAN and core network. Number 6, we'll talk about the trial license details, and then in the end, Q&A. So when it comes to anything, whatever we are doing in everyday job or related to technology or our technical work, the right tools are extremely important. I think I don't have to really stress upon this particular thing. If you can, of course, without the right tools, you can actually do the job, but it will take more time, more effort, it will be more stressful, and it will end up with the poor results. If you use the right tool, you will always save time. Things will be more predictable. You will spend less effort, and you will always end with the better results. So let's jump into the introduction directly. So yeah, I'm showing you basically the poster of a movie, Murder on the Orient Express. It's basically based on the murder mystery novel of the same name by Agatha Christie. Now you will think why I'm talking about a movie or a novel. Yeah, but that's where the connection is. So uh, we are having our own 5G system, whether it is a commercial or it's a open source, right? And then we have got the our 5G mobile. Now the question here is that what is a common piece basically in both the this murder mystery and the 5G network, right? So uh, here in the murder mystery, there will always be a murder, and then the investigator is actually trying to find out who is the right, who is the culprit, and who has done the murder. Looking at all the possibilities, and then applying the mind, and then finally his job is to find the culprit. Now, when it comes to our 5G systems, if we are bringing it up or we are debugging any 5G network, RAM specifically, and then of course we have got a mobile also to talk to the network, then there also we are actually fighting with the sometimes in our work or in our when we are bringing up any 5G network is that the mobile should actually connect with the network, attach, and then it should do the data transfer or whatever things it is supposed to do. Right? So many times it doesn't happen. There can be some issue. The issue can be in configuration. The issue can be in some bug is there for some particular feature or some basic functionality. So the the what happens is that the your 5G system also is not working. So since you are not able to connect to the network, so now I think things are getting clear. So at one place we are actually trying to solve the murder mystery, trying to find out the culprit, and then in our 5G system we are trying to find the culprit. Who is the culprit? Why the mobile is not attaching, or why certain feature in the network is not working. So what is the link? I think it's quite clear now. Will in both the cases, the whole mystery is basically unraveled by layer by layer. So let me tell you that the answer is that the common thread between these two things is we need to the forensic data, right? So in the murder mystery also the forensic data is extremely important. Similarly, to solve the 5G systems issues, the equivalent forensics, that means the logging is extremely important. Based on that, we can try to find out who is the culprit. To facilitate the logging, we need the right logging tools. So today's talk actually is centered around that what is that right logging tool, and then we'll actually also discuss the scenarios. So this logger, the tool is basically to collect log at the COTS mobile site. Now let's first spend a couple of minutes uh, to really understand why do we actually need this COTS UE debugging? Why is it so important? So say typically whenever you are trying to solve any 5G network issues, it may be having some bugs. Uh, and then sometimes if you are using a some vendor specific, the many times you may not be actually having access to the source code, so you cannot really see all the internal state transitions, right? Similarly, the 5G use case lab, the use case lab which have been actually supplied by MMT also to the some of the top professional institute. They also fall in that category because you cannot really see all the uh, all the loads, right? So other thing is that the asymmetric insight. So you will always see that the network, there is a wireless connectivity between the 5G network and the mobile, right? So sometimes depending upon the distance and wireless channel and so many other things, transmit power, receive power, uh, you basically it's not it's very important to figure out how the mobile is seeing that wireless signal, the 5G signal. You may be the 5G network might be sending the good signal, but what is more important is that how is the COTS UE is seeing it, right? So so many times what happens is that if you don't look at the mobile side logs, identifying uh, whether there is some failure, it's very difficult to takes more time consuming and to figure out whether the issue is basically due to the RF conditions or there is some there is some bug in the 5G systems, or there is some protocol non-compliance for some certain feature on the general functionality, or maybe there is some core network bug. So the if you just look at and you have access to the logs on the network side and you just look at that, it's not impossible that you cannot find out the issue, but then it's much more difficult. So that's where the COTS UE is logs is important, because the when you are using the COTS UE commercial of the self mobile, then it has been working in the field for a long time, right? So it has talked to so many different type of networks. It has undergone so many. It's almost basically 99.99%. It works and it is the golden reference. So that's why it's important that you look at the code side, the mobile side logs, because whatever is happening in the mobile side, that is actually the right picture. Okay, so you can multiple things are there. So instead of looking at the network side, the same different layers, whether it is PDCP, RLC, MAC, physical layer, all those logs you can see at the mobile side, and then it will be much more easier to figure out what GMB has sent and whether the mobile has decoded it correctly or not. Yeah, so that's where uh, so we'll be talking about the Mobisync, the 5G logger. So it's very simple to use tool. It's just hooking up to a 5G COTS mobile through a USB cable, and then we are running some software in the host, and it's very simple to use, and then we can see all the logs in our well-known networking software called Wireshark. So using this tool, you can see all the logs, the RRC, NAS, MAC, RLC, PDCP layer 1. And that too, you can see it in real time. So the tool is basically the multi-purpose. You can use it to bring up a new 5G NB. You can use it to diagnose the attach failures if you are not getting the expected throughput, to debug all that type of issues. So you get to solve all these issues using this tool. So that is a general use case. So for example, this may be a commercial network like Geo SA. It can be an open source network. It can be a commercial under the development 5G network. And then the mobile, and then here in the host, we are running the software and it is connected to the COTS mobile through a USB cable. and the COTS UE has got a test SIM which is matching with this core network. So the important thing is that it is very simple to use compared to so many other similar type of logging tools. This is much more easier to set it up. The ramp up time is almost nil. You don't have to really use some dedicated dongles, drivers. Everything happens in the beginning to a setup file, and then we just provide a license file, and we can see all the logs live. We are actually supporting the multiple phone models, which are from OnePlus, Quectel, 5G module, the MMI, Oppo, as well as Samsung. So I will not go into all the points, but the main thing is that here you will see the live Wireshark decoding, whatever is happening in the real time live, that you will see. And then anyway, it works with code swans, and then it's very lightweight, single executable. All the logs you can see clearly, along with KPIs, and then it's supported basically on Ubuntu as well as on Windows also. We don't have any very expensive licensing or yearly renewals. You can actually use it even for 3 months or 6 months also. You will pay only for the essential 5G capabilities, because we are not really including the features from 2G, 3G networks, right? So it's basically developer friendly, and there is scope for a lot of custom extensibility. As I mentioned, it can be used for multiple product development cycle, network bring up. Sometimes the everything is the network is supposed to be fine, but for some reason the mobile is not really attaching and doing the data transfer, or it's not connecting to the internet. Then very quickly you can see where the mobile is stuck. You can quickly find out whether it is an attach issue, registration failure, or if it is connected also, why is it having the low throughput? So exploration and tuning. So if you are using an open source or a commercial network where you are the developer, then it's possible that you are making some changes in the code. You are adding some new features or changing some parameters, and then you find that you change one line of the code, or you change one parameter, and now the mobile is not attaching or is not really working. So that type of issues you can very quickly check with it. Right. So this is these are the protocol and some of the main the messages or capability which we cover. RRC mesh side, all the RRC OTA, NAS decoded messages, all those decrypted messages are covered. MAC side, all the channels related to, means whether it is RAG or the PDSCH, PUSCH, PUCCH, CQI reports, buffer status report. You can actually look at the radio link control stats, PDCP data and payloads you can see. Then physical layer side, you can see all the cell search updates, RSRP, RSRQ, SNR for serving in neighboring cells, and then the whatever anyway channels which are there at the L1 level. All those are their parameters and their DL blur. All that is also getting covered. So you can actually we are also having the live KPI indicators where you can check to what cell ID the mobile is connected, ARFCN, all this RSRP, RSRQ, DL blur, DLMCS, ULMCS, CQI. You can actually also check the PDCP level, DL and UL throughput also in live as it is changing. It's very easy to use, extensible, and then it is fully compatible to the Wireshark. So these are some of the upcoming features. The AI-driven automatic fault identification. So it's possible that these such type of tools, logging tools, are used by some junior developers who still are in learning phase and ramping up, and they don't have so much knowledge of the 5G network and protocols. So the AI-driven automatic fault identification can greatly help them. The another interesting feature is which is planned to be added is the drive test along with the GPS tagging, and then for the mobile mobility, handover and cell selection, reselection, event correlation to aid the developer in the field is also planned to be provided. Yeah, some of these devices I already mentioned. The one thing, important thing which I need to tell you is that it works only with Qualcomm chipset-based devices. So these are some of the screenshots. These are some of the logs which you can configure, or you can configure selected ones, or you can configure the all together. Some of the quick cell parameters are shown here. This is just a screenshot. Anyway, we'll see all these things in our live demo. Various type of messages. This is physical layer, MAC side. Yeah. So now let's jump to the how basically we can debug the 5G networks from the perspective of the different scenarios. We will actually use some particular type of end users. So just this steps, protocol steps, I'm showing just to have a quick recall. These are the type of the messages which are getting exchanged between UE and GNB and between the core network, right? So typically the synchronization, downlink synchronization, then followed by the reading of the SIP parameters by the mobile, and then RAG procedure, and then the RRC attach, connection request, setup and completion, followed by authentication, and then registration. You will see that all this NAS messaging is basically the GNB actually is acting as a just a transport vehicle, and it is passing on to the core network. So the final goal is to have an ADN connectivity so that the mobile gets connected to the network and it is having the internet access. So as the focus of our talk is for a development 5G engineers, suppose the 5G engineer is dealing with open source, or a say can deal with open source, or actually it can be a the closed 5G network. So we'll discuss some 4 scenarios. The scenario number 1, network bring up, means the mobile is not connecting at all. you don't see any 5G indication in the mobile. Then in this second scenario, it is connecting, but then the connection is not stable. Then in the third scenario, it has moved beyond scenario 2. It is having some connectivity, but the uplink and downlink throughputs are quite uh, lower than the expected ones. And in the fourth scenario, the everything else is fine when things are static. That means mobile is all having good throughput, but then you want to test and validate some of the mobility features of the mobile. So let's go into little more detail about the scenario 1. That means you are having a scenario that where you are using a 5G open source network or a commercial network, and you have done everything. It was working, but then for some reason, or it's a brand new. You are just set up your open source network, and it's not basically you have done exactly, you have followed all the steps, whatever was mentioned by the open source code provider, and but still your phone is not attaching, it's not showing any indication that it is connected to the 5G. So where do we start? So uh, basically you have to look at multiple levels. So whether it is the you will think that okay, the first thing is the cell search, right? The mobile has to do cell search and to uh, do the has to synchronize to the basic synchronization to the network through the reference signals as the basically the cell search signals, reference signals, and then then if that is all fine, whether it is mobile is able to see the MIB and SIPs, the RRC setup is steps are happening, or maybe all those are happening, but then it is getting stuck somewhere in the authorization or registration, right? So so basically it comes to the first level where you are actually looking at the cell search and RSRP. Then the on the mobile side, you need to look at the L1 logs, cell search results. So you want to look at the RSRP, how is the signal quality, how is the SNR, and then how many cells are there, what is their the RSRP and SNR, and then you want to see basically whether it is camping to any cell or not, right? And then it's able to see the MIB or SAFE, able to read all these parameter, moving to the authorization and registration, right? So now, so suppose it is able to see it's able to camp onto the cell. So you want to see whether the mobile is seeing the MIB or not. What information is there in the MIB? Because that is the starting point. That's where the basic information of the cell is going, followed by SIB information. And then in our RRC setup, once mobile is able to is able to read the SIBs, system information logs, then the RRC setup, the important, the RAG procedure, the uplink, the mobile sends the RAG signal to the network. So typically, a lot of issues when it happen in the RAG side, the configuration of the RAG and the power. Basically, it will try to do the send the different RAG signals, and then the network, the RAN, has to detect that RAG and then identify that it has come for a certain from a certain mobile. So there is a certain message 1 to message 4. So the RRC setup complete and registration request. Typically, if the RRC setup is complete, then it's quite possible that the uh, the RAN part is all okay. Then if the mobile is getting stuck in this, then maybe it's a some SIM issues or the core network issues, right? So the both authorization request and if the wrong SIM, the whatever SIM programming has been done, it is not matching with the core network, then it will probably fail in the authorization. So if it goes beyond that, then and if it is failing in the registration, or it is not able to establish the PDU session, then very much possible that there are some core related issues, core network, AMF, SMF, UPF issues are there. Right? So, so in all these scenarios, the COTS UE logging is useful because you can see for each step what is happening, whether it is crossed these stages or not. Now coming to the second scenario, where it has gone beyond the registration, that means it is registered, but the connection is actually dropping immediately or after some time, or it's behaving intermittently, or even if it is supposedly connected, it is not really able to see the internet connectivity. So then again, you need to look at multiple type of issues, whether it is a uplink issues, the basically the UL is not able to send the uplink signals, whether it is having some poor downlink RSRP. So maybe it passed through the registration and attach state, but now whenever when the data starts, then the DL blur is quite high, and that's where the U is not able to is decode all the GNB transmissions. It is much more than the typical 10% range. So the DL blur is possible that it's quite high. So in that case, it may not be software bug. Possibly, it's either there is some interference, RF issues, or the transmit power of the radio is too less for some reason, or by the time it reaches to the mobile, the signal is quite poor, or maybe it is seeing lot of interference in the transmitted and frequency carrier, or also it is possible that the antenna is not uh, is not actually performing as expected, and then basically some of the issues can also be that it is the PDU session is getting established, but then there is some UPF routing or some configuration issues in the core network. Due to that, all the data connectivity is not really going through. So the scenario 3, so where things are working as such, but the throughput is, whether it is DL or UL, is painfully low. Like you are thinking that you will get some 150 to 100 Mbps, but what you are seeing is that you are getting only 2 Mbps. So what's going wrong? You need to really find out as a 5G engineer or if you are using the open source, that's all. There also you need to optimize and bring the throughput to the expected range. So when these type of issues are there, then functionality wise things are fine, looking fine from the GNV perspective. But then something is wrong as such, because then why should you have the such a low throughput? So it can have, again, you need to look at multiple layers, starting with the physical layer, RSRP, RSRQ, too very high DL blur, too much of interference, right? Maybe it is not hooked to the best beam. The MAC side, the allocation is not really happening fully. So to look at basically all this information, you can get this for, say, for example, physical layer. You can get all this information from the mobile side logging. Similarly, for the issues related to MAC and scheduler, you can look at all this parameters, the DLUL. If the MCS is too low, then what is happening is that GNB is assigning low MCS. Then you need to find out if it is assigning low MCS, what is the root cause of that. So you start basically with this information, and then you can also look at how is the TB stats on the downlink side, whether it is the buffer status reports will show you whether there is enough buffer for the mobile to that information needs to be sent to the scheduler, so that the MAC scheduler can give more data and allocate more resources to the mobile. And then from the CSI reports, CQI reports, you can find out how is the channel quality. So if the channel quality is poor, then obviously the MAC scheduler will allocate less resources, and then it will tend to allocate the lower MCS. And then the one more region can be, if physical layer and MAC all are looking good, then probably RLC, and you need to look at the RLC, whether there are too many retransmissions are happening at the RLC level. So all that information, the logs, you need to get that information. And then when you have all this information, then you can figure out whether it is a physical layer issue or radio issue, is it a MAC issue, or is it the RLC issue. Hello? So any questions at this moment? Hello? Yeah. So coming to the scenario 4, where everything the mobile is all fine, and it's basically connecting and it is giving good throughput. But then when you introduce the mobility, you move the mobile in the open area. If it is a commercial network, or it's a under the development field deployment is happening, or maybe you have actually open source network or the 5G use case lab. You actually want to test the handover features, or maybe you have introduced you have in the open source code, you have introduced new handover feature. You want to test it. So in all those cases, you can basically if it is a handover, then you are basically you implement it, and then you are looking basically for the RRC reconfiguration message, and also check the cell ID whether it is moving to the different cell. In case of idle mode procedure, this cell selection reselection, typically the mobile looks at the measurement reports, various parameters, and then it is trying to select a better cell. So all those type of things you need to look at the this SIB information to check whether the cell selection reselection is happening or not. And sometimes what happens is that the mobile is for some reason mobile is going to the RLF radio link failure, because something it has gone out of sync for some reason, whether the signal was too poor or the handover failure happened. There is some issue in the PHY or MAC side, and the sync loss has happened. Due to that, mobile goes out of sync, and then it actually detects out of the mobile. In that case, once it detects out of sync, then certain timer is, it waits for a certain timer to expire. The configuration for that timer is done in one of the RRC messages, and then the mobile declares the RLF. And then after that, it will send the RRC re-establishment request. So in all these cases, even though the feature you are testing or you are basically in the network side, but then the mobile side logging is the messages are very important in all this validating the mobility features. Yeah, so here anyway, I'm just telling that how easy it is to debug the open source or any 5G use case network. You just if you are running a 5G network, you have to simply launch the Mobisync on Ubuntu or Windows, and then connect the USB cable, select the logs type, and then click Start Logging. And then once you are able to see the logs on the mobile side, you can actually try to match them with the GMP core logs. So, yeah, let's come to another type of the end user. For example, in academics R&D, the basically the developer researcher is actually introduced a new algorithm in the physical layer. For example, channel estimation in the uplink side. Then such type of things can be easily uh, uh, checked for functionality and performance using all these 4 steps. So if you just replace the original algorithm with the new algorithm of channel estimation, then minimum it should work uh, as good as the original algorithm. So there should not be any problem in that aspect. And if you have designed your channel estimation to give better performance, then you can actually check that by different KPIs on the mobile side, whether it is ULMCS is going up or the UL blur is dropping. So the uplink throughput is more, or the channel quality is improving, whatever it is seen. and then so all that thing you can easily test it. I mean, with real proof. Because if your uplink throughput is going high, uplink MCS is on the is trending upwards, then you know that the new algorithm has done better. So you basically you are able to now prove with the real data that your new algorithm, is working better than the original algorithm by uh, uh, by improving certain KPI, whether it is blur or in terms of throughput, that it has improved by 20%, 30%, like that. Yeah. So then let's come to the another category of the 5G network user. The 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 engineer who actually, or the student who is learned the basics of the 5G in theory, and now he wants to learn the 5G protocols and the networks uh, in practice. So for that purpose also, the this tool is very useful. So they suppose he has learned the basics in theory, right? So he has to just connect the mobile and, for example, the and it has to connect the um, cable, and then start seeing various things, whether it is a downlink cell search, uh, downlink basic data, broadcast information, may save RRC, setup, security, registration, all that he can very well see. So he can see all these different type of messages, reports spread across RRC, MAC, physical layer. So if if he looks at the RRC mass layer, then the whole registration flow is, he can look at each and every message, and then he can relate to the theory. And then if he looks at the MAC side reports, then he can in fact find out how is the scheduler is granting uplink request. Physical layer side, how is basically the RSRP varying, different neighboring cell measurements, PUSCH, PUCCH, SRS details, all that he can see in real. Yeah, that's what the same thing is being told here. So now I will jump to the live demo. Before that, would like to know if any questions are there here. Hello. Mohnish, can you hear me? Subhaiya?
Yes, sir, you are very well audible. Yeah.
Okay. So any questions from the audience at this level about the software, or about any of these the scenarios? So if there are no questions, then I will move to the demo. Let me share with you the demo setup. So what this is the demo setup. So I'm actually running an open source 5G network using the OAI 5G, the RAN, as well as the core network of the OAI only. It is running on one Intel i9 machine, 22.04. And basically it is connecting to a internet through Wi-Fi. Okay, and then this is a full over the air transmission. So I have connected it to a software defined radio SDR. The SDR is basically USRP B210 SDR 2 by 2 MIMO. So the setup is basically 40 megahertz and 78. And then this is the COTS mobile, OnePlus mobile. And I have put the test SIM here, which is having a programmed parameter matching with the core network. And to use our software, I actually connected it to the same host through a USB cable. So you can see that the same host Ubuntu, I'm actually running RAN core network. That is also basically driving this radio, and then same host, same is also I am actually running the Mobisync logging tool, right? So this is how actually my table is looking like. This is the laptop i9 machine. This is the SDR, and the SDR is connected through a USB 3.0, and through another USB uh, uh, port, I have connected it to the COTS mobile. Yeah, let me now. Any questions on the setup? Okay, so this is the mobile. I'm showing it to you through Visor. So this is a 5G mobile, and at present I have kept it in the airplane mode. Let me now show you the open source 5G network thing. So here I've already started the core network. This is a basic core network. So here, this is a Dockerized version, so it's already running. Now I'm going to start the RAN part. So this is a 5G SA network, N78 band. So this is 106, basically, the size of the resource block, the total number of resource blocks. This is the carrier frequency in the downlink side. So now the RAN and core networks are up. Now let me come to our Mobisync logging tool part. So let me show you. Basically, the setup is so simple that when we provide the software to the any user, we provide a license file. We provided a executable, and the first time you have to use the setup file. That is only the first time, which installs all the dependencies, and then we provide, of course, the installation and run user's manual. So now the front end of the tool has come up. It is actually very simple. Deliberately, we have kept it very simple because we don't want to confuse the user by giving too many things. We are only catering to the 5G. So we here things logs related to 5G only are shown. So it is broken into multiple windows. In this window, we are having the MAC, RLC, PDCP. You can either select them individually or you can select all of them. So let me select all of them. And then RRC NAS logs, all the RRC OTA logs, and all the NAS messages. Now this NAS messages, all the decrypted messages are there. And then basic L1 logs. So by default, it is in Wireshark mode. So I will start the logging. So it brings up the Wireshark. Now let me show you. The mobile is in the aeroplane mode. Now let me bring this out of the aeroplane mode. Let me also show you before that what is the SIM which I have put. This is the SIM 100. This is the SIM. Okay. This is the test SIM. And I'm going to now basically bring it out of the aeroplane mode. Okay, so now our thing has started. The software immediately started, and then you can see the KPIs. So you can see that the DL blur is quite low. The ULMCS. This is the now there is not much allocation happening because there is nothing which is running on the mobile side. This is the 2 ports of the DLSNR. You will see that at present there is no DL CQI. The reason for that there is no data here is that the open source OAI core network is not configuring the periodic or aperiodic CQI. So that's why the mobile is not picking it up. You are also seeing this the DL and UL throughput at the PDCP level. Now let me do one thing. I will run some application. You can see that it is already connected to 5G. I will run some YouTube video. So I increase the resolution of the video. You can see that the downlink throughput it is in the range of 30 Mbps or so. Okay, so I will just quickly stop, and I will show you the how easy it is to check all the things. So for example, let's first look at, what we have done is that we have created the multiple filters, D filters. Using that, you can quickly find out. For example, network entry messages. So now that I could have done it actually in the, I started by pressing this, but then I wanted to show the video. So it's taking some time to filter all the logs. But you can always press this live also. So here you will see that you can see all the, say for example, cell search results. Since this is the PCI 0, right? So there is only one beam, and then you can see MIB, SIB, the RRC setup request, the trigger message, basic trigger message. Then you can see all these things, RRC and NAS messages, starting with setup, RRC setup complete. Then you will see the authentication completing, then followed by the registration, and then finally establishment, PDU session establishment completing, and then measurement reports keeps on coming afterwards. Now we can go and have a look at the NAS messages. You can see all these NAS messages. All these messages are basically decrypted messages. Then you have got the MAC messages. So various DCI info you can see. You can see DCI information, TB status, uplink TB stats, uplink frame by frame. You can see the lot of issues happen during the message 1 to message 4. All those message 1, message 2 information you can see when it has happened also, that subframe, exact subframe number, all that you can see here. Message 4. Sometimes the RACH response comes late, all that information. So you can basically can see that when it has come. So if you are tuning the parameters, then that type of information is very useful. The RNTI, whatever, all this information is here. When the contention and has happened, exact subframe and slope number. So here you can see that PUSCH information. Then there is this, so different type of, say for example, CSI reports. But since different CSI reports, since it is not configured, so we may not see any of the relevant information. But basically, you get different type of CSI reports here. Similarly, RLC and PDCP are there. So any questions? I can also show you. Yeah. Let me also show you an handover scenario, which can be actually used to test and validate, debug the handover issues. So this is a already basically this particular log is collected from the IST network lab, where they were running the basically OAI based open source and core network. The core network was different. So there they tested the extend handover feature. So you can see if basically the it's it's connected to cell ID 192. Okay, so yeah, so here this is still connected to 192. The after the extend and over happened by moving the mobile. Basically, the setup was that there are two GNBs were there, and they are connected to the same AMF, and the mobile was moved physically. So then the RRC configuration happened, which means the handover command came. Okay, and then that happened, and then here now you see to what it is now after that completion is happened, then the measurement report shows that it is connected to the second GNB. This LID is 191. Now in the same experiment, the mobile moves back to the original, closer to the original GNB. There you will see that again at this level it has come. So the measurement report shows it is still connected to 191. The after the again handover back to the original GNB, then let's see at the see it has come to the original cell ID. So it's like it went to the second GNB during the extend handover, and once the mobile came closer to the first GNB, it came back to the original GNB. So using this simple, basically we can actually define a while testing this feature, we can have a simple RRC reconfiguration filter. For example, I can just put a filter, and then I hello.
Yes, sir, you're audible.
I think I had to actually fix everything because it was getting stuck because I actually try to overdo the things by loading and unloading the big log files. So is my desktop visible?
Yes, sir, it's visible.
Yeah. So think yeah, live demo wise, think that's what I wanted to show. Any questions on the demo part? So the trial license wise, these are the details. We will share the same information by email also. your registered email, whatever you are used to register for this event. Yeah. So the final takeaway is that using this tool, you can identify the root cause pretty quickly instead of looking at the struggling with multiple type of logs at the GNV side. Using the UE side logs, you can quickly find out where I mean, up to what level the mobile has traveled in the protocol side, and then from there you can actually uh, go towards finding out where the problem might be. Any other questions, doubts? So, think if no questions are there, we can close this call, and would like to thank all of you for joining. I'm hoping that this session was useful, and would really welcome your comments and responses about if any particular thing is required from our side. Thank you, Satish. Feel free to get in touch with us. We are actually giving a 3 months trial for the tool. Anything you want to add, Monish?
No, sir. I think you have covered everything.
Okay, then in that case, thank you once again. And
yes, Satish, I think you can email me and I will connect you with Nitin sir, or if you have Nitin sir's email, that also works for the trial licenser. I've left my email in the comments. You can reach out to me.
No, sir. So this license is only for testing purpose or this is for commercial purpose?
It is up to you basically. You want to, for what purpose do you want to use it for? So what we are basically giving is that the trial license means we are giving you the full-fledged software tool. You can use it for 3 months. Get back to us if you face any problem or how it is helping you, and then if you find it useful for your purpose, for your use case, then you can think of buying the tool.
Actually, sir, I want to use for this our learning purpose for
Right.
the protocol stack development.
Okay.
So for that, it is how it is useful.
Yeah, so I think I covered that part in my talk. Since you can look at all the protocol state side, means all these steps of the network attach, and you can look at each and every parameter also, whether it is the downlink cell search, looking at the MIB-SIB information, or the RRC setup steps, followed by authentication and then registration, and in the end, EDN connectivity. So whatever happens between mobile and the network, all the protocol steps, um, all those steps you can see here, each and every parameter in all those messages is the number of total parameters will be, I think, maybe can be possibly thousands also. So means whatever you have gone through in your theory, you can actually see it in live. For example, if you use the tool, and you have got a Ubuntu or Windows machine, then you can actually use the tool even to look at the commercial geo networks, right? Where
Okay.
everything is working, you can look at each and every information, what parameter they are using, what configuration they are using. Uh, if you
Means
do
that this is a kind of lab, right? You can say lab setup.
basically, you can use it for whatever, wherever you find it. I mean, for whatever purpose you want to use it, because this tool is it does not matter what network, what 5G network you use. You use open source 5G network, or you use a commercial network, or you are in a company and you are debugging or developing some certain feature in a network. Anything. I mean, since the logging is on the mobile side, so
Mhm.
it does not matter which network you are 5G
Okay.
network you are using.
Okay. So in this
The,
setup means except UE, all part will cover WAN or core, right?
those are anyway the under the test, na?
Okay. Okay.
So basically, say for example, uh, suppose you have got a uh, so your own 5G mobile, right? And suppose it is one of the make which we support,
Hmm.
right? Then what you can do is that you suppose you are having a geo sim, you are having you are using geo sim, you are connecting to the geo network.
Hmm.
Correct? So simplest thing which is possible is that you will connect the USB cable to the your mobile, enable some certain do some certain settings in the mobile, and then run our tool, and then you can see each and every parameter and of the geo network. What is the cell ID? What is the RSRP? What is the RRC parameters, SIB parameters? What REG parameter they have used, configurations, everything you can see. The core
Oh,
network details and in the NAS messages. It's whatever happens between mobile and network, everything you can see.
okay,
That,
sir. Okay.
that is the simplest use case.
Okay, sir. And also one more question, sir.
Yeah.
So there I can check, can we check the code level instruction also?
Uh, Code level.
Code, or we can see the code for the all the layers,
Uh,
which the code is
you mean network GNB side?
yes.
Uh, so basically, this is a tool for the mobile. But
Okay.
if you use an open source network, like the example which I used, so I was using open source desktop network, correct?
Mm-hmm.
So there, all the source code is available.
Mm-hmm.
You need to connect a software-defined radio, actual radio.
Okay,
Uh,
means the actual radio is required.
Basically, yeah, of course, you need, since you are doing everything related to the over the air,
Mm-hmm. Mm-hmm.
so you need the software radio.
Okay. Okay.
So it means I don't know whether if you are working in a company and you have access to a software-defined radio, like the make which we are using, then of course you can use open source, and then you can connect a 5G mobile to that network. You can
Okay.
that, you have access to all the source code, means each and every line of the open source RAN,
Mm-hmm.
and you are
Okay.
getting it all for free, except that you need to have a software-defined radio.
Okay. Okay, sir. Thank you.
Yeah, thank you. Any other question? I think I saw one more questions from the Kiran. Okay, so
Yeah,
you yeah.
thanks for sharing all this information. I just have a doubt. Do you have any connection setup guide available with this
For the
5G and mobile, and along with the logger?
Yeah, actually, the all the installation guide and everything is there on the uh, basically on the uh, GitLab site of the
Okay.
Open Air Interface 5G.
Open Air Interface 5G.
Yeah,
Okay.
you can see everything there. Yeah, but suppose yeah.
And this logger executable, where can we get from?
Yeah, for that you need to connect to us.
Okay,
We will
sure.
provide you that logger executable.
Okay, got it.
Yeah.
Do we really require SDR for
Say
the testing purpose
you
home
need
setup?
SDR if you want to set up the open source network.
Okay.
Okay, but if you have, suppose you want to just explore the geo network, or suppose you in your company, by any chance, you have access to a commercial network, then you need to put the matching SIM in the mobile and then use the tool to now test and debug your commercial network. But
Okay.
yeah, if you want to use open source 5G network, then you need SDR.
Okay. Okay. Yeah. Got it.
Right? Did I answer your question, Kiran?
Yes.
Yeah. In any case, if you have any doubt, please feel free to contact us.
Sure. Do you mind sharing any email ID for the reference?
Yeah, it is. What I will do is that I will share the Monish actually has shared in the chat.
Oh, okay.
But at the same time, I will also send the email to all the registered users of this talk,
Okay.
and then you can reply
Yeah.
back to us.
Moni shared his mail.
Yeah.
Yeah.
And you can also find me on the LinkedIn, and then you can reach out to me.
Sure. Definitely.
Okay.
Thank you.
Yeah. Okay. Thank you. Thank you, everyone. So we'll close the call, Monish and Bixby team.
Sure, sir. We can
Okay.
close. Yeah.
Yeah. Thank you. Thank you so much.
Thank you everyone for joining.
Thank you.